The most common problem when working with numerical data is about the difference in magnitudes as we mentioned in the first lesson. An easy fix for this issue is standardization. Other names by which you may have heard this term are feature scaling and normalization. However, normalization could refer to a few additional concepts even within machine learning, which is why we will stick with the term standardization and feature scaling. Standardization or feature scaling is the process of transforming the data we are working with into a standard scale. A very common way to approach this problem is by subtracting the mean and dividing by the standard deviation. In this way, regardless of the dataset, we will always obtain a distribution with a mean of 0 and a standard deviation of 1, which could easily be proven. Let's show that with an FX example. Say our algorithm has two input variables, euro-dollar exchange rate and the daily trading volume. We have 3 days worth of observations. First day 1.3 and 110,000. Second day 1.34 and 98,700. And the third day 1.25 and 135,000. The first value shows the euro-dollar exchange rate, while the second one shows the daily trading volume. Let's standardize these figures. We standardize the euro-dollar exchange rates regarding the other euro-dollar exchange rates. So, we look at 1.3, 1.34, and 1.25. The mean is 1.3, while the standard deviation 0.045. Going through the above-mentioned transformation, these values become 0.07, 0.96, and minus 1.03 respectively. Standardizing trading volumes, we obtain minus 0.25, minus 0.85, and 1.1. In this way, we have focused figures of very different scales to appear similar. That's why another name for standardization is feature scaling. This will ensure our linear combinations treat the two variables equally. Also, it is much easier to make sense of the data. The transformation of trading volumes allowed us to transform the volumes from 110,000, 98,700, and 135,000 to minus 0.25, minus 0.85, and 1.1. In this way, the third term is considerably higher than the average, while the first one is around the average. We can confidently say that 135,000 trades per day is a high figure, while 98,700 is low. Please disregard the simplification of having just 3 observations. That's just an example. Besides standardization, there are other popular methods too. We will shortly introduce them without going too much in detail. Initially, we said that normalization refers to several concepts. One of them, which comes up in machine learning, often consists of converting each sample into a unit-length vector, using the L1 or L2 norm. Another preprocessing method is PCA, standing for Principal Components Analysis. It is a dimension reduction technique, often used when working with several variables referring to the same bigger concept, or latent variable. For instance, if we have data about one's religion, voting history, participation in different associations, and upbringing, we can combine these 4 to reflect his or her attitude towards immigration. This new variable will normally be standardized in a range with a mean of 0 and a standard deviation of 1. Whitening is another technique frequently used for preprocessing. It is often performed after PCA and removes most of the underlying correlations between data points. Whitening can be useful when conceptually the data should be uncorrelated, but that's not reflected in the observations. We can't cover all the strategies, as each strategy is problem-specific. However, standardization is the most common one, and is the one we will employ in the practical examples we will face in this course. In the next lesson, we will see how to deal with categorical data. Thanks for watching.